Early marine life in the shallow seas. The Trilobite Age. By the dawn of this period of relative quiet on the Earth's surface, life is confined to the various inland seas and the oceanic shoreline. As yet, no form of land organism has evolved. Primitive marine animals are well established and are prepared for the next evolutionary development. Amoebas are typical survivors of this initial stage of animal life, having made their appearance toward the close of the preceding transition period. 400 million years ago, marine life, both vegetable and animal, is fairly well distributed over the whole world. The world climate grows slightly warmer and becomes more equable. There is a general inundation of the seashores of the various continents, particularly of North and South America. New oceans appear, and the older bodies of water are greatly enlarged. Vegetation now for the first time crawls out upon the land and soon makes considerable progress in adaptation to a non-marine habitat. Suddenly, and without gradation ancestry, the first multicellular animals make their appearance. The trilobites have evolved, and for ages they dominate the seas. From the standpoint of marine life, this is the Trilobite Age. In the later portion of this time segment, much of North America and Europe emerged from the sea. The crust of the Earth was temporarily stabilized. Mountains, or rather high elevations of land, rose along the Atlantic and Pacific coasts, over the West Indies and in southern Europe. The entire Caribbean region was highly elevated. 390 million years ago, the land was still elevated. Over parts of Eastern and Western America and Western Europe may be found the stone strata laid down during these times, and these are the oldest rocks which contain trilobite fossils. There were many long finger-like gulfs projecting into the land masses in which were deposited these fossil-bearing rocks. Within a few million years, the Pacific Ocean began to invade the American continents. The sinking of the land was principally due to crustal adjustment, although the lateral land spread, or continental creep, was also a factor. 380 million years ago, Asia was subsiding, and all other continents were experiencing a short-lived emergence. But as this epoch progressed, the newly appearing Atlantic Ocean made extensive inroads on all adjacent coastlines. The northern Atlantic or Arctic seas were then connected with the southern Gulf waters. When this southern sea entered the Appalachian Trough, its waves broke upon the east against mountains as high as the Alps. But in general, the continents were uninteresting lowlands, utterly devoid of scenic beauty. The sedimentary deposits of these ages are of four sorts. 1. Conglomerates matter deposited near the shorelines. 2. Sandstones deposits made in shallow water but where the waves were sufficient to prevent mud settling. 3. Shells deposits made in the deeper and more quiet water. 4. Limestone including the deposits of trilobite shells in deep water. The trilobite fossils of these times present certain basic uniformities coupled with certain well-marked variations. The early animals developing from the three original life implantations were characteristic. Those appearing in the Western Hemisphere were slightly different from those of the Eurasian group and from the Australasian or Australian Antarctic type. 370 million years ago, the great and almost total submergence of North and South America occurred, followed by the sinking of Africa and Australia. Only certain parts of North America remained above these shallow Cambrian seas. 5 million years later, the seas were retreating before the rising land. And all of these phenomena of land sinking and land rising were undramatic, taking place slowly over millions of years. The trilobite fossil-bearing strata of this epoch outcrop here and there throughout all the continents except in Central Asia. In many regions these rocks are horizontal, but in the mountains they are tilted and distorted because of pressure and folding. And such pressure has, in many places, changed the original character of these deposits. Sandstone has been turned into quartz, shale has been changed to slate, while limestone has been converted into marble. 360 million years ago, the land was still rising. North and South America were well up. Western Europe and the British Isles were emerging, except parts of Wales, which were deeply submerged. There were no great ice sheets during these ages. The supposed glacial deposits appearing in connection with these strata in Europe, Africa, China, and Australia are due to isolated mountain glaciers or to the displacement of glacial debris of later origin. The world climate was oceanic, not continental. The southern seas were warmer then than now, and they extended northward over North America up to the polar regions. The Gulf Stream coursed over the central portion of North America, being deflected eastward to bathe and warm the shores of Greenland, making that now ice-mantled continent a veritable tropic paradise. The marine life was much alike the world over, and consisted of the seaweeds, one-celled organisms, simple sponges, trilobites, and other crustacean shrimps, crabs, and lobsters. 3,000 varieties of brachiopods appeared at the close of this period, only 200 of which have survived. These animals represent a variety of early life which has come down to the present time practically unchanged. But the trilobites were the dominant living creatures. They were sexed animals and existed in many forms. Being poor swimmers, they sluggishly floated in the water or crawled along the sea bottoms, curling up in self-protection when attacked by their later appearing enemies. They grew in length from 2 inches to 1 foot and developed into 4 distinct groups: carnivorous, herbivorous, omnivorous, and mud-eaters. The ability of the latter group largely to subsist on inorganic matter being the last multi-celled animal that could explain their great increase and long survival. This was the biogeologic picture of Eurasia at the end of that long period of the world's history, embracing 50 million years, designated by your geologists as the Cambrian.